When life throws a curveball at you, it's how you react that matters. Canceling the conference was never an option. Not for us and not for you. Thank you so much for attending.
If you have any questions, we are available on Slack. We also have a WebEx meeting where you can meet us in person at the info booth channel.
To all of our speakers waiting to present to you from their homes, thank you so much for speaking.
To all our fantastic partners, thanks for sticking with us through this. You rock. These are awesome companies. Special thanks to our exhibitors. You'll find them at our virtual expo. Make sure you visit them. There are some amazing prizes to be won. We'll do live prize draws during every lunch break.
Thanks to the Agenda Committee for putting together a fantastic agenda. You did a great job.
So wherever you are in the world, we hope you enjoyed the show.
Anything you want to add to this, Dylan?
Good morning. Good morning. Good morning. Welcome, everybody, to NDC London 2021. Big hello. Let's get away from all the folks who are watching live on WebEx. Let's get a big shout out in the chat from all the folks who are watching live on YouTube. Hello, everybody. It's great to see you all. And for me, I actually get to welcome all of you to a place I actually am. It's been a very strange year for conferences. This time last year, we were here in the city of Westminster, which is the city inside the city of London. And NDC London 2020 was in full swing. We had about 1,000 people. We had 5 days of workshops and content and tracks and parties and PubConf and all that kind of stuff. Now the world has changed a little bit since we last did that. We are still doing NDC, of course we are. Cancelling it, like Alan said in the video, cancelling it was never an option. And at NDC London last year, I did a presentation in the last slot on Friday about a thing called the art of code. Now, this was kind of a bit of fun for me. It's a talk that I put together about things I wanted to talk about. It was a sort of meandering riff through art and fractal geometry and esoteric languages and music and stuff. And I know how bored you have all been since all the lockdowns and the pandemic restrictions and everything started. Do you know how I know how bored people have been? Because 1.8 million people have watched that Art of Code video since it was put up in February last year. I say 1.8 million people. About half of that is me going and refreshing it to see if the numbers have gone up yet, because lockdown is difficult for extroverts and our egos need a little buzz wherever we can get it. But a lot of people have watched it, and a lot of people seem to have liked it. And, when we started thinking about putting NDC London 2021 together, the crew said to me, do you fancy doing a keynote that's something kind of like the Art of Code? And, somebody said to me, well, have you got anything else to talk about? I'm like, what? You think I took a 1-hour talk and I literally said everything there is to say about the interplay between art and music and computers and programming and creativity? We have only scratched the surface, because there are so many more ideas to explore and things to talk about. And what I want to share with all of you this morning to welcome you all and kick off NDC London 2021. The title of this talk is Computational Creativity. And I was bouncing around a whole bunch of ideas, and what I wanted to do was take a look at some of those same ideas about this synergy that exists when human beings and technology combine to create something interesting. Håkan says, can't see slides. Yes, thank you, Håkan. There we go. So, computational creativity. Now, I just kind of came up with this phrase while I was playing around with some ideas and things. And a little while ago, I was reading this book. This is Sid Meier's memoir. You may know Sid Meier. He's the game designer who built Civilization, or Civ 1, 2, 3, 4, 5, a game where the integer overflow means Gandhi turns into a nuclear terrorist. You ever played that one? And Railroad Tycoon and a whole bunch of different games. And I was just kind of reading this book, and I stumbled across this little lovely phrase. This phrase, computational creativity. It cropped up, and I was like, hey, I thought of that. Sid thought of that. That's kind of nice. He's using it in reference to a project that goes way back to the 90s about building computer games that can generate original murder mysteries. So you can play a detective and you have to solve crimes, and every time you play it, it's a different mystery with different clues, which I think is a lovely idea and possibly a subject for another talk. But there's also a phrase just before that in the book where he says, it was only a little bit impossible, which is not the same as completely impossible. And I was thinking about that phrase, because I was thinking, if I'd said to the rest of the crew this time last year, hey, next year we're going to do NDC London over the internet and nobody's going to be in the room, they'd all have said, no, that's impossible. But it's only a little bit impossible. It's not completely impossible. And so here we are, and here all of you are, streaming, watching live from all over the world. Marco says in YouTube comment, Pirates! Yeah, Sid Meier did the Pirates game as well. And all his games end with an exclamation mark, which I really liked. Now, as you probably all know by now, when we run these kinds of online events, we're relying on a huge amount of technology to keep everything working. There's a rule that says the success of a performance is directly proportional to the number of meters of cable that are involved. Well, we've probably got something like 200, maybe 300,000 kilometers of cable involved in me being able to talk to all of you this morning. So if anything goes wrong, don't worry about it. Just relax, check your Twitter and everything. We'll reboot the thing. We'll be back up with you as soon as we can. But let's get started. Let's kick off NDC London 2021. And we are going to start at the beginning. We are going to go back in time about 40,000 years. These are some cave paintings that were discovered in Indonesia in 2019. And these cave paintings, archaeologists believe this is the oldest art ever, the oldest evidence they've ever found of human beings creating art. And there's two things about this that I think are wonderful. One, we were making art. As soon as human beings worked out, hey, we can use this stuff to make marks on the wall of the cave, they're like, what should we draw? And the other thing, the archaeologists who've studied this, they've discovered it shows a hunt. There's this big animal and there's a bunch of little human figures you can just kind of barely make out that are hunting it. But one of the human figures has a bird's head and another one of the human figures has a tail. And so it's fiction. It's creative. As soon as people worked out they could make marks on a cave wall to show this hunting scene, they're like, let's make something up. What can we do? What can we put here? This idea of using technology to explore things that don't really exist and, fiction, fantasy, imagination, I think that's a wonderful idea, something that I want to dig into. Now, those cave paintings started this long tradition of visual art. We had a Michelangelo, we had Da Vinci, we had Frida Kahlo and Hokusai, and all of these different schools and styles, sculpture, sgraffito, oils, paintings, watercolors. And in around 1840, a group of artists based in France founded a movement that they called realism. The realists were fed up of, romanticized pictures of John the Baptist and King Louis. They wanted to paint real life as accurately as they possibly could. They painted real scenes and they strove for... It wasn't called photographic realism because the phrase didn't exist yet, but they wanted paintings that looked like reality. Ordinary people just going out and doing ordinary things. But even as the realism movement was getting started, its days were already numbered because the second half of the 19th century, we saw a technological innovation that was going to change the world. We saw the advent of photography. Now, as soon as cameras were invented, film cameras and then motion cameras and eventually digital cameras, realism was effectively obsolete. If something really happened, you could just point a camera at it and capture it. Why would you strive for days meticulously recreating reality with brush strokes when you could just point and shoot? Now, the early film cameras, you had to sit very still for a very long time. It was a very expensive proposition. But one of the things we've seen with every form of technology is as soon as we figured out how to do it, it starts getting easier and cheaper and easier and cheaper. And we went from, old black and white films to compact films to 35mm to digital to smartphones. And now it seems like, almost everything that ever happens in the world, somebody took a picture of it or took a video of it because photography is absolutely ubiquitous. So next time and whenever this may be, next time you're out with a group of friends and you're having some drinks and someone goes, hey, let's get a selfie, spare a thought for the realists, a group of humans and a whole avenue of human endeavor that was just sort of rendered obsolete by technology. This photograph, by the way, I would like to credit it, but I don't know who it's from. It was posted anonymously to Reddit as a response to the question, what is the drunkest photograph you have ever seen? And, I think it's beautiful. I'd almost like to get a realist painter to recreate this just to close that loop. But photography was just one example of, technology having this profound impact on the way people interact with the world around them. From 1760 until the middle of the 19th century, the world experienced an industrial revolution, the industrial revolution. Textiles, agriculture, mining, manufacturing, hundreds of, human beings and the industries in which they worked were dramatically changed by machinery and automation and technology. And, the impacts of those changes are still visible today. Some of you may have come across this word Luddite, which is, not terribly complimentary term that's applied to people who just don't want to get with the program when it comes to technology, right? People, I've had, he's a Luddite, he doesn't want a computer on his desk. Bunch of Luddites, they don't want to join an online conference, they don't want to get a smartphone, this kind of thing. The term Luddite is actually named after a person who's portrayed here as a man called Ned Ludd. Ludd was a weaver. and he destroyed a pair of looms. He took a hammer and he smashed up a pair of textile weaving frames because he was worried, he was angry that these machines were coming along that were going to replace the craft of weaving, human beings making textiles. Maybe it's true, maybe it's a folk story, but Ned Ludd's name has gone down in history as sort of synonymous with this fear and destruction of technology. And, you know, you think about it, weaving used to be something that artisans did, and if you had woven cloth, that was a status symbol. And suddenly overnight they're like, no, we got machines that can just kind of churn out this stuff. And so, you know, we have this word Luddite in Ned Ludd's honor centuries later. But for every innovation that technology delivers, there are always going to be the people who embrace that change. People who look at it and they go, you know, this is amazing. We can work with this. We can do things with this. And there are the people who are going to resist that change. And those changes, they raise all kinds of questions about innovation and creativity, liability, and that's what I want to talk to all of you about today. We're going to fast forward to the 1950s. In the 1950s, the word computer was a job title applied to human beings. Any companies, organizations that needed to do arithmetic, the military, aviation, engineering, they employed computers. Halls full of them. Human beings who'd sit there all day with pencils and paper and slide rules, and they would perform calculations. Now, if any of you read the book or seen the movie Hidden Figures, the movie came out in 2016. It tells the story of a group of computers, people who were working at NASA during the 1950s, doing calculations for the United States space program. They're the people who did the calculations that put Alan Shepard in orbit and landed Apollo on the moon. And if you've seen the movie, you probably remember this scene, right?
The IBM 7090 data processing system. It has the capability of solving over 24,000 multiplications per second.
Holy Moses, that's lightning fast.
They'll never get that to work.
Oh, it'll run eventually. And when it does, we have to know how to program it. Unless you'd rather be out of a job.
No, ma'am.
So the actress there, Octavia Spencer, is playing a real person called Dorothy Vaughan. And Dorothy worked at NASA until 1971. She was one of the first people to work on programming one of the first IBM mainframe systems in an early version of Fortran. By the time Dorothy Vaughan left NASA, human beings had walked on the moon. We'd invented the Hewlett-Packard Pocket Scientific Calculator, the Intel 4004 microprocessor, which was the kind of the earliest version of the instruction set that we still use today. The 4004 processor had been released. Xerox had invented the laser printer. The ARPANET existed. IP addresses were a thing. Email was a thing. And the word computer was definitely not a job title anymore. And we had started to struggle with this whole idea about the dialogue between human beings and technology and the extent to which it's okay to rely on them. Now, I'm sure some of you are of the generation that had the arguments with your teachers when you were in school about whether you were allowed to use a calculator. Now, I had the teachers would be like, you have to learn your times tables. And I'd be like, why? I have a calculator. And they'd say, well, when you grow up, you won't always have a calculator in your pocket. Hands up anyone who has a calculator app on their phone, and their phone is in their pocket right now. I'm sorry, Mrs. Marshall. It turns out when we grow up, we all have calculators in our pockets. But, arithmetic is not that big a deal. Arithmetic, as distinct from, mathematics, arithmetic is not very creative. You do a sum or an equation and you get the right answer. And it doesn't matter how you got there. You don't get bonus points for doing it in an interesting way. All that matters is how do we get the right answer? The faster the better, especially if you are trying to beat the Soviet Union to land the first mission on the moon, right? And so the whole idea of calculators, well, yeah, if you need to do sums in a hurry and they need to be right, of course you'll use a calculator. Don't do it by hand. What are you doing with that? Now, when I was in school, I was kind of a nerdy kid. And in the early 1990s, my folks had a computer that I used to use to do my homework. I would write essays and things. And I got into these ongoing arguments with my teachers about whether I was allowed to use a spell checker. Because there was one school of thought that said you go to school to learn to read and write and spell. If you use a spell checker, that's cheating. And there was another school of thought that says this technology is available and you should learn to use it, because if it means that you write better essays, kind of who cares how they got there? And we eventually, after lots of negotiation, arrived at this very, very weird compromise where I was allowed to use a spell checker for like history and geography homework, because my English teacher was like, those subjects are not teaching you how to spell, but you're not allowed to use a spell checker for doing your English homework, because if you make spelling mistakes, I need to be able to correct them. And, you know, I sort of said to her, but a spell check works just like a dictionary. And she said, no, if you look words up in a dictionary, then you'll find out what they mean. And I said to her, why would I be using a word in my essay if I don't know what it means? And this kind of went back and forth in a fairly good-natured way. But the point is, you know, dictionaries, spell checkers, all this kind of stuff, they're not actually creative tools. All they're doing is taking what you've given them and saying, hey, did I find that in this list over here? And the classic problem with spell checkers was immortalized in this wonderful poem by a guy called Gerald Czar. I have a spelling checker. It came with my PC. It plainly marks for my review mistakes I cannot see. I strike a key and type a word and wait for it to say whether I am wrong or right. It shows me straight away. Now, when I wasn't in school arguing with my teachers about calculators and spell checkers, I was a teenager in the 1990s. And it was kind of fun. And the coolest thing that happened when I was a teenager doing Mrs. Jones' English class was that this movie came out. Terminator 2 Judgment Day. Terminator had everything. It had Arnold Schwarzenegger, and it had time-traveling killer robots from the future, and it had a Guns N' Roses soundtrack, and it had all those one-liners, hasta la vista, baby, and all that kind of stuff. And it had some of the best visual effects that anyone had ever seen in a motion picture. The team from Industrial Light and Magic who put this together, they were using computer technology to realize things that, you know, nobody had ever seen on a cinema screen before. We'd never seen anything like this. You know, we had this liquid metal robot that could change its shape to mimic anything that it touched, which became a kind of, you know, pivotal point, and it won loads of awards for the effects. It was an absolute smash hit blockbuster movie. But Terminator 2 was not the first movie that used computers. 1982, Steven Lisberger directed and produced this movie. It was released by the Disney Corporation. It's a film called Tron. It's a film about computers, made using computers. The story of a programmer who gets sucked into the mainframe and has to fight his way back out against all kinds of evil corporate programs, which is a sort of parable for developers working in the enterprise everywhere. And the story of how Tron got made was absolutely fascinating. Tron combined hand animation, computer animation, and live action in a way nobody had seen before. Take a little look at this.
This is Blue Leader to Blue Bikes. Run these guys into your jet walls.
Copy, Blue Leader. Copy, Blue Leader. This is Gold 1 to Gold 2 and 3. Split up. Take them one-on-one.
Tron was one of the most visually stunning movies ever made. Tron did not win any Academy Awards for visual effects because it was disqualified. The Motion Picture Academy of Arts and Sciences, the people who give out the Oscars, they said that using computers to make a film was cheating. It just wasn't in the spirit of the thing. Now, you know, at the time, the Hollywood machine employed thousands of set dressers and carpenters and animators and makeup people and costume people. And you can see why, you know, they're like, they can make a movie on a computer. What are all these people going to do for a job if they can do that? Now, you know, obviously that's not quite how it went down. Computers just became a sort of another tool in the filmmaker's palette, filmmaker's arsenal, you know. But the Tron was actually all the animation. It was funded by Disney. Disney paid for it, Disney distributed it. But all of the animation was done in Taiwan because Disney's animators refused to work on it. They said, we are not kind of, putting nails into our own coffin here. We are not prepared to work with you on this. Now, the really interesting thing about that is Tron wasn't the first movie to use computer graphics. There were computer graphics before that, but they were always, like, in the film, there would be a computer on screen with graphics on the computer screen. And Hollywood kind of thought that was fine. As long as they stay in the computer and it's obvious they're in a computer, then that's all right. We're not worried about that. But there were also, at the time when Tron was made, it was cheaper to fake it. This is from John Carpenter's Escape from New York. Snake Plissken flying his glider into Manhattan to go and rescue the president who's been kidnapped by gangsters. And look at the navigation display on his plane here. That looks like a green screen wireframe computer graphic, right? It's not. That is a warehouse full of cardboard boxes. They have been painted black, they have had a stripe of green paint put along all the corners, and the second unit director on that movie got one of those ultraviolet disco lights, and he just walked through it with a movie camera, so you got this gliding effect. The person who directed that scene was James Cameron, who went on to make Terminator 2 and Titanic and found his own digital effects company, Digital Domain. So if you wanted computer graphics on a screen in the 1980s, the easiest thing to do was to fake it with cardboard and string and, ultraviolet light. To make Tron, they used this thing. This is a computer called the Foonly F1. It was the only one in the world. It was a massively overclocked PDP-10. And they would take 6 hours to render a single frame of footage, and then they'd press a button and it would expose one frame of the film, advance the film, and then they'd press render on the next thing. They couldn't combine human beings and computer footage in the same shot. So anywhere you see people on screen, those computer graphics were drawn by hand, and the scenes where you just see the machines and the sets and things, those are all computer generated. The Academy eventually came to their senses. They realized that, yep, that's probably fine. If you want to use computers, then that's all right. We'll let you do that. And they gave Tron a Lifetime Achievement Award in recognition of how it had changed the motion picture industry. But let's think about a shot like this one, from Terminator 2, because by the time they made that, the balance had flipped, and computers were making, you didn't have to fake it anymore, the computer would just kind of spit out what you asked for it. And this raises a new question. You look at this shot here. Now, you got the liquid metal robot reflecting the floor, and the directors lined up the shot, but that robot wasn't there when they filmed it. That was put in later with a computer running an algorithm written by a programmer who wasn't a movie director. So who gets the credit? Who created that shot? And in Terminator 2, it was very much kind of storyboarded. Robot comes out of the floor, looks like this, and they'd have pencil sketches, and they just try and achieve that. But about a decade, 15 years later, we started seeing scenes like this. Now, in these scenes, this is from Peter Jackson's Lord of the Rings trilogy. This is 2002. The computer isn't just rendering. The computer isn't just the animator. All of those soldiers on that battlefield, they are being played, acted by the computer. It's a system called Massive that combines AI routines with routing path algorithms, behavior algorithms. And so the director can say, give me 20,000 orcs over there, 20,000 elves over there, big trebuchet war machine in the middle, boom, action, let them fight. So there's no human acting going on. There's no human costuming going on. And the director just kind of goes, right, bring the camera around here, almost like they're shooting reportage footage on a real battlefield, There is a lovely story about this. When they first put these things on the screen in the Return of the King movie, some of the little computer-generated extras saw the Mumalak war elephants, and they turned around and they ran off the battlefield. And there was an interview with one of the, Weta was the company, one of the artists said, well, actually, all that was happening was they realized that over there was crowded and they were looking for empty space because we had a kind of frequency distribution algorithm. But the story of these little digital soldiers getting terrified and running away was too good to pass up, so we let that one go around in the press for a couple of years. But so far, so good. It's fantasy. It's obviously not real. We know that this was not filmed on location in Middle-earth and that no war elephants were harmed during the making of this movie. But then this guy comes along.
I believe I owe you an apology, Director Krennic. Your work exceeds all expectations.
Now that character is Grand Moff Tarkin, who first appeared on our cinema screens in 1977 in the first Star Wars movie, played by the British actor Peter Cushing. Peter Cushing is dead. Peter Cushing died, I think, in 2003. And so when the makers of the Star Wars Rogue One movie wanted to bring this character back, you know, they had this, do we recast it? Do we, replace it with a different character? What do we do? And it raised all sorts of interesting questions. There was a review of one of the Star Wars movies that said, we live in an age where computers mean you can have dead actors playing living characters and living actors playing dead characters. I just want to show you a tiny little snippet from the ABC Nightline program from the team who did that, the Peter Cushing Grand Moff Tarkin effect, because it's really insightful seeing how they put it together.
Underneath digital Tarkin is a real actor, Guy Henry, who carefully studied Cushing on the set.
Lost in the attack.
It's Henry's voice and performance that the ILM artist used as a guide.
The original plans for the station are kept there, are they not?
Charming to the last.
This is the earliest test. It's the first time we ever saw Guy's motion transferred onto Guy's model and then put onto Tarkin's an early likeness.
The problem is Cushing's performance and Henry's performance didn't always match. That required painstaking, sometimes frame-by-frame adjustments, constantly refining the most subtle details you can imagine. The makers of Rogue One had the blessing of Cushing's estate, but the effect is drawing some criticism over the ethics of bringing back well-known actors long after they're gone.
Now, anyone who's seen the Cats movie will know that sometimes computers they give filmmakers too much power and they do things that just should never have been done. We should have stopped before we got to that point. But so far we talked about Hollywood. We talked about, big budget, lots of, professional animators and everything. And we are entering an age now where you don't need Hollywood anymore, Take a look at this.
We're entering an era in which our enemies can make it look like anyone is saying anything at any point in time, even if they would never say those things. So, for instance, they could have me say things like, Killmonger was right. Now, you see, I would never say these things, at least not in a public address, but someone else would. Someone like Jordan Peele. This is a dangerous time. Moving forward, we need to be more vigilant with what we trust from the internet.
So that's what has become known as deepfake technology, which is almost at the point where you can go, here's a bunch of photographs of a famous person or somebody I know. Here is me talking to camera, make it look like they were doing the talking, and it will spit out video footage that is frighteningly plausible in a lot of scenarios, which raises questions exactly as it says in the piece here. Who do you trust? How do you know who to trust? And what happens if that trust relationship is abused? Now, historically, we have had a rigorous framework of laws around publishing and people being responsible for what they decide to say. If a newspaper printed a story on their front page that I was having a romantic liaison with Jar Jar Binks, I can sue them. If that wasn't true, and we'll assume that it's not true, I could sue them because they have made a decision. There was a conscious agency involved in doing that. Somebody said, we are going to print this story. Either we believe it's true, in which case they are negligent, or they know it's not true and they print it anyway, in which case they are malicious. In either case, I can sue that newspaper for damages. Damage to my reputation. Now, obviously, with newspapers, the only things that make it onto the printed page are the things that the journalists were paid to put there, the editors look at it, the copywriters look at it, the whole thing has people involved at every step of it. As the internet started to take off and pick up steam, we realized that we were going to have a problem. And in the 1990s, there was a window where it looked for a while like internet providers, ISPs, might be liable for anything that was transmitted over their network. Imagine that. I'm on a network ISP called PlusNet right here at home right now. So if I go on a website and I see something I don't like, I can sue PlusNet. I can say, yeah, your network showed me something that isn't true. I'm suing you for it, you know. This was obviously going to threaten all sorts of possible and potential revenue and content and business models for the internet. And so the freedom from these kinds of restrictions very quickly became codified in law. In the United States, where it kind of has the most impact, it's called Section 230 of the Communications Decency Act. No provider or user of an interactive computer service shall be treated as the publisher or speaker of any information provided by another information content provider. What that means is that if I say something about you on Facebook, that's my problem. That's not Facebook's problem. If you want to sue, you got to sue me. You can't sue Facebook. You can't sue your internet provider. You can't sue my internet provider. You can't sue the people who provided the undersea cable which allowed your provider to talk to my provider. I am the publisher or speaker, and nobody else will be treated as the publisher or speaker. And, you know, I think this is a good thing. The Electronic Freedom Foundation thinks this is a good thing. It is one of the most rigorous protections of online free speech. It's also, you know, imagine trying to run a website like GitHub or Stack Overflow if you could be legally liable for anything that anybody said. You know, somebody puts a defamatory comment about Bill Gates in a GitHub repository somewhere, and someone decides they're going to sue GitHub because they don't like it. You know, it would make a lot of the social media and collaboration platforms we rely on effectively unworkable. But it was all based on the idea that the platforms were neutral. Within the last probably 5-10 years, we've seen a shift away from neutrality on those platforms, but it's not because the content on them is being curated by human beings. If you go onto Twitter and you go and click the options in the top, you get this thing. Home shows you top tweets. What are top tweets? Now, top tweets means that something somewhere in Twitter's giant infrastructure is looking at all of... There's no way you can keep up with Twitter. There is too much of it. And so this algorithm, the top tweets algorithm, it chooses things to show me that it thinks I am going to engage with. Because the drive here is engagement. People, clicks, eyeballs, attention span, things that Twitter can sell to advertisers. If you are not paying for a service, you are the product and they are selling you to somebody else. That is the mantra of how social media revenue models work. So if the Twitter algorithm decides that I'm interested in stories saying, you know, giving a particular editorial perspective on something like the US elections or the coronavirus pandemic, you know, is anybody liable? Is there anybody involved in that who I can go and say, you showed all these people something that wasn't true, and as a result, we now have these problems to deal with, you know? Because it's not a human being making the recommendations. Much as we'd like to think it is, there is no editor-in-chief working at YouTube or Facebook or Twitter or any of these platforms. You know, it's just recommendation algorithms. And the thing you've got to remember about the recommendation algorithms is they are optimizing for the perfect YouTube viewer is somebody who wanders in one afternoon and goes, look at this YouTube thing everyone's talking about. And they never go outside again. Because the recommendation algorithm is doing its job so well that at the end of every video, there is another video. You know, YouTube, end of everything, it says, what do you want to watch next? And it's probably me doing Art of Code at NDC London. But it's never going to be, hey, that's enough YouTube for today. Go outside, you know, phone your mother, get some fresh air, maybe drink a glass of water. That is never the recommendation. Hey, you know, read a book, talk to somebody, go and have a chat with your neighbor. It's always, here's another video. And the videos that you watch to the end, they feed into the algorithm. And the videos that you skip halfway through, they're like, all right, well, it doesn't like that. No more of that kind of stuff. Now, this is just, you know, it's not a good or an evil algorithm. It's just an algorithm that has been optimized to encourage a particular pattern of behavior. And I think some recommendation algorithms are fantastic. I listen to Spotify a lot. And Spotify has This Is Your Daily Mix. And I'll just be like, you know, Spotify, just play music, and it'll just start picking tracks, and it'll be like, I love this song. I've not heard it in years, and I'll be, you know, dancing around the kitchen, singing and playing air guitar and stuff. And it's YouTube's recommendation algorithm randomly one day popped up and said, you should watch this. It's a guy in Switzerland who restores rusty old machine tools that he found. And it's mesmerizing, and it's wonderful, chill out. It's called My Mechanics, and it's just no dialogue, no music. It's just a guy with a bunch of tools fixing up all these battered old machines and appliances and stuff, and it's wonderful. But, all this stuff, this idea about running algorithms and everything, it raises questions, is it the algorithm? Is it the reliability of the underlying platform? Is it the people who spec the algorithm, the people who built it? How does all of that work? We're going to take a step back. We're going to look at the whole thing now from a slightly different perspective. Because I want to talk about a company who had a memorable experience when it comes to using algorithms to make recommendations. It was a company called Knight Capital. In 2012, Knight Capital was the single largest equities trader on the New York Stock Exchange. They accounted for something like 17% of all the trades on the New York Stock Exchange, and the same on the NASDAQ, the high-tech share trading index. Now, in 2012, the New York Stock Exchange introduced some new rules. They said, we're changing the regulations to make it a little bit easier for people to use automated systems to help, automate the process of buying and selling stock. It's going to roll out in August 2012. So the folks at Knight Capital, they upgraded their software and they made a bunch of changes and they got everything ready to roll out to integrate with the new retail liquidity program. And on August the 1st, they rolled this upgrade out onto 8 servers. They had 8 servers in their trading cluster, except they made a mistake. They actually only rolled it out onto 7. Now, this is where it gets probably relatable for anybody who's worked on big legacy systems. Inside their algorithmic trading system is a system called SMARS. There was a feature that they called PowerPeg. And PowerPeg's job was, if you said, I want to buy 10,000 shares of that, PowerPeg would be like, all right, that company has 280 for sale. Grab them. Okay, bring it down. How many do we need now? Right. That company, grab them. How many? And eventually it'd be like, right, that's it. We've got all 10,000 shares. PowerPeg had been stopped. They'd stopped using it 9 years earlier. So this code had been sat dormant in production for nearly a decade. They had removed the transaction limit feature. That, for some reason, just wasn't there anymore. But it was okay because it wasn't running, because it was switched off using a feature flag, using a configuration flag. The people who put in the retail liquidity index changes, they reused that feature flag. So when they rolled out the new configuration, 7 of the servers started trading on the new stock exchange rules, and one of them reactivated the old PowerPeg code and started issuing trades. The transaction limit feature was gone, so as soon as somebody said, hey, buy 1,000 shares of that, we basically had an infinite loop spending real money doing trades on the New York Stock Exchange. The Securities and Equities Commission report on this is very short, and it's surprisingly funny for a financial report. It includes this memorable phrase: they had accumulated an unintended multi-million-dollar portfolio of securities in approximately 45 minutes. They had bought $460 million worth of stock they didn't want because of a loop in an algorithm that they didn't realize was there. First thing that they did when it started going wrong is they rolled the code back on all the other 7 servers, but they didn't reset the config flag, so now they had 8 servers spending real money on stuff they didn't want on the stock exchange. It basically wiped the company out. They lost $500 million, and they had to pay a $12 million fine, which has really got a sting when you've just lost $500 million. And, the questions that I have, they went down in history, it pretty much wiped out Knight Capital as a trading thing. This was their stock price over the course of that incident. And they've gone down in history as a really good example of what not to do that's useful for people like me who write talks about famous incidents from stuff. But, who's to blame? The engineer who, do you ever in your job, do you roll out upgrades onto servers? If you missed one, do you think that should be a $500 million mistake? What about the people who implemented the code, reusing the feature? Does that sound like a $500 million mistake? I'm sure at some point there was a meeting where somebody must have said, I think the transaction limit on PowerPeg might not be working. And somebody else said, oh, don't worry, we haven't used that code in 10 years and it's going to be removed soon anyway. These conversations, they are worryingly familiar to anybody who's worked on big IT systems, because a lot of the institutional knowledge just kind of gets lost. That stuff gets shut down, but it never really gets deleted. And just occasionally something that wasn't supposed to wake up wakes up, Now, the Knight Capital incident, although it was, a catastrophic thing for the company, the share price, and potentially the entire stability of the stock exchange, it is still possible to trace through every single step. All that system, SMARS, was doing was it was doing what human traders might have done, which is look at the market, decide what might be a good idea, and put in a bid and try and buy it. It was just doing it fast, really fast, like hundreds of millions of times per second. But with enough time and resources, it was possible to unpick the whole thing, roll it all back, and figure out, okay, so this happened, and then this happened, and then this happened, and then this happened. We are now getting into an age where it is no longer possible to do that. As we start exploring things to do with, machine learning, convolutional neural networks, we can build systems that they behave in a certain way, and we're like, oh, okay, well, that's what they do, I guess. There's an interesting example of this from Amazon, recruitment. Now, there's recruitment is a huge challenge. Anyone who's ever been looking for a job or been hiring engineers for your team, recruitment takes up a lot of time and energy for everybody working in software. And, that's one of the two fundamental truths is recruitment is hard, job hunting is hard. And another fundamental truth is if you give nerds a problem that takes a lot of time and effort, they will try and figure out a way to automate it. And that is exactly what Amazon did in 2014. They took all of the resumes, the CVs of everybody who had ever applied for a job with Amazon, and they said, we want you to scan all of these, and we want you to look for the patterns. We want to find out a way of looking at a CV, feed that through the algorithm and say, do we hire this person, yes or no? And, they had good, rigorous data on this. They had records of everybody who had applied, how far they got through the interview process, whether they subsequently got a job. So they put a team on this, and they ran through all these CVs, ran a bunch of different models, and, it worked. They discovered a very, very strong set of patterns. What they discovered was that Amazon's hiring policy was systemically biased. They discovered that if your CV had the name of a college that only admitted women, you probably didn't get a job with Amazon. They discovered that certain kinds of sporting and recreational activities outside university that are generally popular with women, if those appeared on CVs, those people probably didn't get a job. They found other outliers, but then when they flipped it around, they said, well, who did we hire? There was no pattern at all. What they had discovered is that it wasn't a policy, this wasn't official, the emergent behavior of the hiring procedures that were in place at Amazon were effectively, get rid of take out the women, take out people who don't look like us, and then we'll just randomly hire some selection of the people that we have left. Now, they say they never ever used this thing in production. It was a research project. It led to some, fairly difficult conversations around how the whole hiring process at Amazon was working. The algorithms were working. They found the patterns. It's just that the patterns they found were not patterns that anybody expected or wanted to see in there. And, this is an interesting example of applying machine learning and unearthing some systemic bias in the models that they were thinking, hey, we can train a machine to do what we do. And the machine does it, and they go, oh, the machine is doing horrible things. Are we doing horrible things? Now, this happens all the time. Here, I want to share something with you. I first ran this a couple of months ago, and it was like, oh, wow, that's interesting. I'm sure that's going to be fixed soon. And yesterday, I went in and I replicated the experiment, posting images to Twitter. Now, Twitter, when you upload photographs to Twitter, it does some machine learning analysis and it finds the faces in the photographs. And it applies a crop to try and highlight the bit of the picture that it thinks you want to see first. Now, it does this, it's only Twitter's official web and iOS client. It doesn't happen on third-party things like TweetDeck because the metadata is only in Twitter's own system. It's not in any of their third-party APIs. So what I did last night, I went on Twitter and I was like, all right, let's post this picture of Nelson Mandela and Vladimir Putin, and then I'll post the same picture, but the other way up, with the pictures in a different combination. Let's see who Twitter decides to highlight. And Twitter goes, yeah, here's the relevant part of that picture, even though the composition is opposed. So I tried a couple more. I'm like, all right, let's try Kanye West and Jacinda Ardern. And it got Jacinda in both cases. Beyonce and Jay-Z? What do you think this one's going to come up with? This one got Beyonce in both of them. I tried 3 copies of Barack Obama and Homer Simpson, and Twitter went, Homer. both cases. And finally, just because, this was not a rigorous experiment by any means, I was curious. I was looking for material to use in this talk and for a bit of insight into how to start thinking about this problem. I fired up Photoshop and I made a Harrison Ford wearing a Denzel Washington t-shirt and Denzel Washington wearing a Harrison Ford t-shirt. And this one, it went, no, actually Denzel Washington is the most interesting face, whether he's on a t-shirt or not. So there is some bias going on in this algorithm somewhere. The question is, how did it get there? Now, Twitter said, oh, we're going to fix this, and that was months ago, and they haven't fixed it. So go and talk to Twitter if you think that they need to fix this thing. What I'm interested in is, I don't think anyone sat down and said they're going to do this on purpose. I believe that what we are seeing here is a kind of systemic problem that emerges from a failure to acknowledge the bias in the underlying data sets and the composition of the people who are working on these things. It's about 8 billion people on this planet. Now, things like ethnicity and gender, they are not absolutes, they are a spectrum. But if you got all the human beings on the planet and you said, look, anyone who identifies as white guys, you come and stand over here, everyone else stay over there, you'd get about that many, maybe around 10%. So if that's your sample set, and you as an engineer have an algorithm that you're like, it's 98% accurate because you've tested it on a biased data set and then you've maybe tested it on your coworkers who also exhibit some of the same bias, your algorithm is actually more like 9% accurate when you apply it to real people. And, that's not good enough in all kinds of ways. From an engineering perspective, the lack of precision is horrible. From a moral and ethical perspective, it's excluding, huge swathes of people who are like, well, I guess their algorithm just doesn't care about people like me, right? So what are we going to do about it? Well, first thing we have to do is we need better data. A lot of the problem with facial recognition stuff is that the public data sets consist of famous people. And the famous people tend to be the kind of people who get famous in our society, and a lot of them tend to be white guys. Politicians, leaders, heads of state, movie stars, sports people, all these kind of people, there is an overwhelming bias towards people who are Caucasian and present as male. And so you get this huge corpus of 10,000 photographs that you found on the internet to train your machine learning model. There's bias there, You haven't done anything malicious, you just haven't realized that there is this problem. And so you build it and then you try it out on all the other people in your engineering team, and you probably have a similar problem. You maybe don't pick up that the bias exists, because again, there is a problem with the makeup of those teams not being representative of the planet as a whole. So we need to look out for this. We need to start being aware of the bias in the data sets we're using to train these things. We need to start being aware of the bias in the teams that we're trying it out with. Try and find a bunch of people who are nothing like the folks who sit next to you in your office or who join your Slack every morning. Be like, can we work with you on trying to get this thing right? And we're going to change the world. And that sounds audacious, but think about the number of things that we have changed already by identifying the right problem, finding the people who care about it, and getting them to try and solve it. We are right now having a conference, even though nobody is allowed to travel. We have invented writing and language and electronics and radio and transistors, internet, email, Wi-Fi, mobile apps, streaming video. The amount of technology involved in doing what we are doing right now is absolutely astonishing. And, it can seem like the world is a little bit of a bleak place, but if you look at some key metrics, look at things like a life expectancy, access to healthcare, access to information. Hans Rosling, the guy who used to work with statistics at the United Nations, he had this wonderful one. Number of playable guitars per person in the world has been increasing steadily since the 1950s. So on all kinds of metrics, the world is a better place than it's ever been, and it is still getting better. And if you need information, you need to know how to repair a tractor, to fix a broken bone, or identify a parasite that's destroying your crops, that stuff is there. And it's online, and it's free, and it's in hundreds of languages. And it's accessible to everybody, not just the people who can get library cards. Even kids can get online and look this stuff up, I grew up in Zimbabwe. I lived there until I was about 10 years old. And if I wanted to know something, I could ask my parents, I could ask my teachers, or I could go to the library, which was okay. That was not the hugest library in the world. It was the Borrowdale School Library in Harare. But for really important questions, my questions as a kid were like, how fast can a BMX go? Could a BMX go to space? Who'd win in a fight between Optimus Prime and Darth Vader? I had no idea. Of course, now you can Google this stuff, and you can go on, and it's like, I'm not even actually going there. But if you have these kinds of questions, it's easy. And if you have important questions about health, about, identity, about gender, and there's nobody you can talk to, people all over the world, they can go online and they can type it into Google and they can get answers back saying it's okay. Yeah, it's normal. No, you're different to all the other people who live in your little town. That's cool, Come out into the world and you'll find people who like you, and it's absolutely fine. Don't worry about it. And I think that's worth it. I think that's valuable, and if it takes us a couple of decades to deal with fake news and Russian troll farms and figure out a balance for the whole thing, I think it's worth it. Absolutely. Because, think about how much we've accomplished. We've wired the planet, we've got blanketed the sky with satellites, we've trapped lightning in rocks until they learn how to think. And along the way, we've learned things about the universe, we've learned things about ourselves. Now, we've talked over the last hour about a whole bunch of different models of computation. We've talked about number crunching, arithmetic, high-frequency algorithmic trading, spell checkers, machine learning, information networks, and somewhere, in the background, there's always this question, what kind of computers are we? What sort of computational model does the human brain use, and will we ever be able to create an artificial one? And there is a classic quote from Edgar Dijkstra. He said, the question of whether a computer can think is no more interesting than the question of whether a submarine can swim. Now, there's a lot to unpack there. And part of the problem is we use the word think to, what is thinking? Our thinking is what brains do. What do brains do? Oh, they think. Think about that. Think about thinking. The word think in English, what is 127 plus 255? Oh, I think it's around 200 and 370 something. How do I get to the library? Oh, I think it's up there across the street. I think I want a sandwich. I think I love you. I think Jimi Hendrix is massively overrated. Those are not the same process. Those are not the same kind of computational model. We are just using think as an umbrella term for stuff brains do, and then being like, why can't computers think? It's like, well, you haven't phrased the question properly, I want to look at one specific kind of cognitive process to close this out today. I want to look at, playing a game of chess. Now, turns out the oldest chess programs are actually older than computers. Alan Turing wrote one of the first chess programs on pen and paper, and about 20 years later, somebody finally built a computer capable of running it. But for a long time, people were better than computers at chess. Then in the 1990s, it kind of got neck and neck, and then Garry Kasparov, the world champion grandmaster, was defeated by an IBM computer called Deep Blue in 1997. By the mid-2000s, it was game over. The computers were consistently winning every time. But after he was defeated by Deep Blue, Garry Kasparov created a new kind of chess. He called it advanced chess. Some people call it centaur chess, cyborg chess, hybrid chess. And the idea of centaur chess is that each player is a human and a computer, playing against another human and a computer. How good can they get if the humans and the computers are working together on the same side? And in the early days of cyborg chess, what they discovered was that like a home computer with a reasonably good club chess player could beat a human grandmaster. Because there was something about those two complementary analytical styles, human creativity and mechanical computation, that just made them a stronger chess player. And one of Kasparov's observations about this was that the differentiating factor here, the thing that kind of controlled who won or lost, wasn't the player or the computer, it was the quality of the interface that existed between them. How quickly could the person have an idea, get it into the machine, and understand the response that said, no, don't do that. If you do that, it's a definite back rank mate in 16 moves or something. The quality of that interface, the synergy that exists between the person and the machine. And so that now brings us onto the home stretch. Because I took this idea about applying, how can we create collaborations between human beings and computers in a domain that I'm interested in, which is music. Now, at NDC Oslo in June 2019, this guy, Michael Lusak, he presented a talk about using a machine learning model to write heavy metal riffs. I'll show you a tiny little excerpt from that talk here.
So, yeah. So, I'm gonna play this. So, it's not maybe a great piece of music, but it has some nice parts. And it's, you know, if you play it with enough overdrive, could be actually qualified as metal.
If you play it with enough overdrive, it could actually be qualified as metal. Challenge accepted. Now, we have some music. I emailed Micha and I said, hey, can I have a copy of your TensorFlow models and stuff? And he sent those over. And, you know, I took that music that his model created. He fed it all of the guitar music to all of Metallica's albums and then said, write me a new Metallica song. That's what it came out with. You got music. I wanted lyrics. Now, the state of the art for getting machines to write text at the moment is a thing called GPT-3. And GPT-3 is a machine learning algorithm that generates English based on a brief. Last year, The Guardian newspaper published an article written by GPT-3. They just gave it a brief. They said, you know, this is the thing. You're going to send an email to this neural network that is the kind of email you'd send to one of your writers, your freelance journalists, and you're going to publish what it sends back. And it wrote, I am not a human, I am a robot, a thinking robot. I use only 0.12% of my cognitive capacity. I am a micro-robot in that respect. I know my brain is not a feeling brain, but it is capable of making rational, logical decisions. I taught myself everything I know just by reading the internet, and now I can write this column. My brain is boiling with ideas. A machine created this. Now, the article that The Guardian ran, what they actually did was they took 8 different versions and they picked the best bits. And someone said, isn't that cheating? And they said, no, that's exactly what we do with human journalists, is we'll move bits around and edit and structure and things. Now, I've been trying to get access to GPT-3 for about 6 months, and I still haven't, probably because I told them I wanted it to make Metallica lyrics. So for the lyrics of today's exercise, we are going to use a slightly more pedestrian computational model. We're going to use something called a Markov chain. Now, Markov chaining is just about taking a whole bunch of text and using statistical probability models to go, if I have this word, what word might come next? I'll do a very, very quick worked example for you. If we took a Markov chain and we trained it on Hotel California by Eagles, and then we said, right, write me a line of lyrics starting with she. Now, in Hotel California, she does various things. She stood in the doorway. She lit up a candle. She showed me the way. She got the Mercedes-Benz. And so it's just going to pick one of those at random because the model knows that those words can follow she. Let's go with she showed. What did she show me? Well, in the original song, she showed me the way is the only thing she did, so that's always got to be me. What comes after me? Me the way, bring me my wine. Me why, 50-50, we'll go with that one. And what are the my things in Hotel California? My hair. My sight grew dim. Bring me my wine. We'll pick one of those at random. Boom. She showed me my hair. There we go. That's a line of Eagles lyrics. Now, it's not terribly meaningful, but it's kind of, you know, it's grammatically consistent, and it captures something of the flavor of the original piece, right? And there is a website called lyrics.rip. that has Markov chained all the lyrics to all the bands ever, and you can just go on there and you can type in, if you go on YouTube, there's a guy out there who's performed all these kinds of songs, and he writes his own music to go with the Markov chained lyric things. And I thought, let's go on lyrics.rib, let's get Metallica and get that to generate some Markov chained Metallica lyrics. And I did. And I plugged them in, and then I curated what I found. I took Michal's computer-generated music, and I took lyrics.rip's computer-generated lyrics, and I went through them. I was like, right, that goes there, that we can't use, and created this. So who wrote that song? Did Metallica write it? Did Michael write it? Did TensorFlow write it? Did I write it? I don't know. I don't think anybody knows, but it still exists as a result of this wonderful synergistic collaboration between machines and computers. And I am gonna wrap it up there. Thank you very much, everybody, for watching. Thank you to the folks out on YouTube there for tuning in this morning. If you want to see the rest of the conference, get a ticket. ndc-london.com. You can still grab yourself a ticket and come join the rest of it. Thank you very much to all the folks out there watching on WebEx. We are out of time. If you have questions, I will be on Slack, conference Slack, for the next 3 days. Come and find me in there. I hope you all enjoyed that. I hope you enjoy the rest of the conference. You got 3 days of amazing talks, presentations, content, ideas, case studies. It's going to be absolutely fantastic. Join me at 8 o'clock tonight for the NDC virtual pub quiz. Join me tomorrow evening. We're going to be doing a live stream party with a whole bunch of music and comedy and all of those kinds of things. And don't forget to check out all of our sponsors over on the virtual NDC Expo. There's links to that in the conference Slack for those of you who are watching. YouTube folks, it's been a pleasure. Take it easy. Have a wonderful day.